Hello, everyone, and welcome. I'm Molly. I'm a marketing associate at the Passivhaus Trust, and I'm really pleased to welcome you to today's session in our Passivhaus Retrofit Case Study Lunch and Learn series. Those who have been before will know that we developed this programme in response to growing interest in retrofit, particularly following the Guy Martin programme, The House Without Bills, which was broadcast on Channel 4 in February. And it actually prompted homeowners to start asking questions about what high quality retrofit actually looks like in practice. So in this session, I'm absolutely delighted to be joined by Richard Dudzicki from RDA Architects, who will be sharing the Timberyard conversion. This is just one of many amazing projects that we're featuring in the series. And so we'd recommend that you do register for the last few sessions. And if you have missed the first few, they will all be available on YouTube soon. So a very quick note on how the session will run. The presentation itself will last for about 25 to 30 minutes, and then we'll have time for questions and discussions. This session is particularly aimed at homeowners, including those who may be at a very early stage thinking about retrofit. If I can just hand over to Richard to present the Old Timberyard. Thank you, Richard.
Hello there, and thank you very much for listening to my dialogue about how we built our house. So the Old Timberyard is a project that took a number of years to build over the lockdown period. It is an old Victorian building, as you can see from the initial slide, and it used to be our offices. As architects, we specialize in difficult and tricky sites. We work with a lot of refurbishment and effectively new buildings, smaller buildings in and around London. We've been on our sort of sustainable journey for the last 25, 30 years. I started building and working with the Passivhaus Trust back in 2011, 2012, when we built our first passive house. Before that, we were working with sort of code level buildings in Harlow and so forth. So we had worked with sustainable buildings, but I hadn't really known much about passive house. And really, the issue for us is how much have we saved and how much energy and primary energy have we saved by doing all of this? Well, it's a lot, as you can see from the slide. It's a considerable amount. And what we've done is over many years, we've created many projects and we've learned from them. And when it came to building our own house, as our teenage kids were getting older and larger and so forth, we were rattling around in a 100 square meter home, a little bit less than that. And it was too much when the kids were around 13, 14. So we decided to go on a planning journey with planning permission and make an application to convert our old offices because we couldn't afford to move really. And that was the only place we could really we had as a building. And I bought that a few years ago, and my daughter was born there actually. And what we ended up doing was going on the journey effectively of trying to convert that and make it a larger space. So that took a number of years fighting for planning. Now, this slide is something which is about EnerPHit. It's quite important about primary energy costs, and it's something I do believe quite considerable. A lot of our building stock needs deep retrofit. This particular office was derelict. It was really getting to the point where the roof was leaking, solid brick wall, and it needed a lot of work. Just working out and doing some very simple calculations, we worked out that by over a course of 60 years, we could actually save ourselves around £86,000 in energy bills by going for a deep EnerPHit project. And an EnerPHit is different. It's effectively you're taking an existing building and converting it. One of the things that LETI, which is an organisation of consultants effectively, are trying to do is shift the peak of energy demand and the energy demand of effectively the housing stock in London, or well, not in London, but all over, and trying to shift it over to be more ecological. And it's something I wanted to contribute to, and also my partner and my kids, all of us were very keen on this. So it's something that the whole family embarked on as a project. There's many trepidations with this. So what did we read about? We looked at RIBA's Passive House Overlay. We looked at RIBA's, the RIBA, Royal Institute of British Architects, the Climate Challenge. We're trying to reduce the energy, LETI's Climate Emergency Guide and so forth. We were using these sort of, these we were using these sort of this literature to try and ensure that we had the same idea, all of us. When I was a student, this is many years ago, I studied architecture in Liverpool Poly in the 80s. And I remember we used to go to CAT, the Centre for Alternative Technology in North Wales. And it was very much a bunch of people listening to Pink Floyd sitting around composting toilets and so forth. But look at it now. So there's definitely been a change in the ether and the air. Those pioneers did something. They did something to me as well, because it's something that I believe in. So, what are the key principles of passive house design? Well, the key principles are insulate your house well, make sure it's airtight, create and put in high performance doors and windows, include mechanical ventilation and heat recovery, ensure that you have thermal bridge free design. That means that you effectively have a tea cozy over the building. How do you do that with an existing building? It's very hard. It's very difficult to do that. And so you have to do things whereby you look at the existing building. What's the aspect ratio? How are you going to be able to do that? The fact is, we had quite a lot of knowledge because we had lots of examples of how we actually did this before. So we've done it since 2011. So we had a bit of a track record, and we were thinking we had this building. We was just thinking, how can we do this? Do we insulate the building on the outside? Do we do it on the inside? And we started putting figures into Passive House Planning Package, and we were playing around with different ideas and different ways of actually how we would go about doing this. And we're putting all the different aspects and playing around also with costs. How can we do this with a cost basis which is affordable for us? I mean, I wasn't borrowing a lot of money, and this was effectively a new home for us and the family. So, common misconceptions, and this is what builders put across, this is what people put across to you when you start saying, well, I'm building an EnerPHit house, or I'm building a passive house, or I'm building something. They say it's too technical. Well, it's not. You just need to use a consultant. We work with some consultants called Ecospheric, who are fantastic, and we also work with a good certifier, a chap called Kim Mead from Mead Consulting. And so, working with the right people, talking to people from the Passive House Trust, it's easy. You just learn. It's going to cost a fortune. That's a classic mistake. No, not at all. Not necessary. Just talk and discuss it. None of the builders we used had worked on Passive House before. None of them. We just talked them through. And believe me, I did this all on direct labour. So I just worked with contractors throughout the process. So I didn't use one main contractor. I used multiple different contractors for different stages of the work and just explaining it all along the way. It takes too long. Well, in our case, it did take a long time. It did take a long time because we started the build in December 2019, and then COVID came along. So it did take 2 years. It was supposed to be a 1.5 year, 18-month project, but it just took over 2 years to build. So it did take a long time. But in this particular case, that was mainly due to COVID, not to do with building a passive house. So where is the timber yard? As you can see from this site plan, the timber yard is located in a street block in Zone 2 of London, so it's sort of Peckham East Dulwich borders. And it's surrounded by 13 other buildings and a substation. You access the building towards the southwest, and effectively what you get from there is a long alleyway and a front garden. You don't really have many windows at the back towards the north. And so it's effectively a southwest, northish elevation. You don't have many windows there, and all the windows really face onto the front of the building. It's a long, narrow building. What was it like? Well, that's what I bought back in 2000. In 99, 2000, that was the building that I actually bought. So it was a really difficult building to work with. We had to skim the site, and that became our offices. It was RDA's offices, very first offices we had, and we basically converted it on a budget, and that's really where we moved to. Where the scrapyard is at the moment, at the front there and at the back, we built another little house, 100 square meter house, which we lived in, but it was just tiny. It was really small, so we needed more space. The kids had grown up and got older, but now some of you might have seen with their kids are now moving back in with their girlfriends and boyfriends respectively into our house. And this is what we were trying to achieve. So this was the render that we did in ArchiCAD, and we worked with a number of different render solutions, and that's what we ended up doing. So here's a brief history. The brief history is the building was an office for a timber yard, then an office for a scrap yard, then it became offices. My daughter was born there, so we lived upstairs and the office was downstairs, and we just changed to windows. But the flat roof was past it. It was really cold. It was really cold. And then in 2019, we effectively started work to convert it into an EnerPHit, which is the bottom slide there. So really, what space did we include and what did we increase? Well, we created a small extension to the front of the building. So to the front, we created this area in light blue, and we expanded on the basement, which was there. We had to underpin the building as well, as the brickwork was too short effectively, so we underpinned that. And then we also created the new loft space. So you can see there what the additional space was. Pretty much, it's a long, narrow building. So the form factor, and what I mean by the form factor is how economically the shape is designed. It's a long box. It's not a square box, it's a long box. So it's not that great from an insulative point of view and from a point of view of passive house. But the fact that it's quite tall, then it worked okay. It wasn't too bad, but it worked all right. So we did need to put a lot of insulation into the building. You can see there on the details that the insulation went on the inside. The elevations were designed, and the reason we chose a barrel roof, some of you may be asking why, was basically to maximize the upstairs space. We had a real issue with height. We couldn't go any higher than this, and we were also had an issue with the eaves level as well. So to try and maximise a little bit more space, we used a curve, and that curve gave us more space in the upper rooms. Albeit the windows are quite low there towards the front. In the studio, we ended up using roof lights for the roof, and they're Velux roof lights, but they're Velux Passive House roof lights. The airtight membrane. How do you deal with this? Well, we ended up doing the airtight membrane on the inside of the building, and the inside of the building of the brickwork, that's pretty much where the airtight membrane was. And you'll see where it all how it lends itself. But it was quite a difficult task. That was probably the trickiest task in all of this, harder than planning, harder than anything else. So when we were thinking about this, we're thinking, my God, we've got to put all the insulation on the inside, like a tea cozy on the inside of the building. And at the same time, we've got a steel structure going in as well. How do we deal with the details? Well, dealing with the details was very much to avoid thermal bridging. So we had to start sketching the details out. How does the steel go into the brickwork? How do we separate it? How do we insulate it? How do what do we use to break this steel away from the existing brickwork? So we spent a lot of time sketching out the details, working with these, and working in transit with the engineers we had, which were fantastic CTP engineers down in Sevenoaks. They were really, really useful, really, really nice people. And again, this was all just before lockdown, and we were really trying to get as much information out as possible, but they were helpful. And at the same time, whilst we were doing all of this, we were working, even at early stages, we'd worked with the Passive House planning package. And we're putting all this data into the Passive House planning package. And the nice thing is, because we do this as a day-to-day aspect in the office, it's something we know about and we can work with. And there's people in the office here who can work with this. We were going back and forth with Ecospheric, we'd work with them, and we'd work with Kim Mead, the certifier as well. So that was really quite helpful. So we could test. And we were testing everything beforehand, which was really, really useful and making sure we could get this all done. And at the same time, we were borrowing the money from the bank to do this. We were getting a loan, effectively a bridging loan to do the work until we could mortgage the building. This is a graph that was produced by Ecospheric, and it was primarily to look at, it's Ben Riddle at Ecospheric who produced this, and it was very much to deal with the embodied carbon. What was the embodied carbon? What were the savings? And that was something which was really interesting, that we were saving so many kilograms of carbon over a period of time, over a year effectively, and in terms of the carbon by retaining the brickwork. So what was the concept? Well, the concept was very much putting a building within a building. So we kept the brick shell and then we constructed a building within a building. And again, working on tricky sites, we're thinking, God, how are we going to get all this steelwork in there? Well, that wasn't easy, but we managed to sort of think about it and componentize it so we could carry it, we could bring it in. And then effectively what we were doing with the existing building, it was 120 square meters, we were increasing it to 237 square meters. We were creating a 5-bedroom house. We were replacing the windows with Passivhaus to Passivhaus standards, and we created a new mechanical and electrical strategy for the whole building. So that's what I mean by M&E design. We worked out also, my whole family got involved with the interior design, and by building it all in 3D and having a 3D model of the whole project in BIM, Building Information Modeling System, we could play around with all the materials and everything else, and we knew what we wanted. So one of the things that was really important for us was to try and limit the amount of VOCs. Both my kids have sort of like quite a few skin allergies, so it was something very important to us to use lime render, to use items that were healthier. So it wasn't just about a passive house, it was also about healthier homes. So we started the work. We had problems. We've got 13 neighbours and we couldn't put the scaffold up around the neighbours to do the roof. So we had to break through the building. So we had to create holes to get the scaffold through the building and cantilever the scaffold through the building to get the roof on, which we managed to. But there, what you can see is that was the brickwork. It's a solid brick wall. And you can see the brickwork of the existing building, which we'd covered with a parge coat. So we'd done a parge coat of lime render effectively on the entire brickwork to try and make sure it's airtight. And we'd fill those holes with a scaffold was cantilevered through at a later date. That was the first real stage. And then we sort of started thinking about, well, we also worked with the existing building and underpinned it. Whilst underpinning it, we effectively cleared out some space in the existing undercroft and basement area, and we damp-proofed that. So there, what you can see is the delta membrane. You can see the damp-proof membrane, so we could actually, because that's below ground level. So that also has to be insulated. So that's where we didn't use wood fibre in the sort of lower ground in the basement area because it's below ground level. That is where it's tanked with a delta membrane, and therefore we didn't actually allow that to breathe. But using the MVHR and the air circulating throughout the building, this building doesn't get damp, it hasn't got any interstitial condensation, and it works really well. Now, one of the interesting things, as you can see, is the steel frame as it was going in is separated from the main building. And we used ferret plates. We then used nanogel insulation behind that steel. So where you see that little piece of timber at the bottom there, that's where we used a little bit of nanogel insulation because the insulation on the inside is about 150 mil thick. And then what we've also got is we used the steel pads that go throughout the building there are raised up off the ground on ferret plates. So they again don't touch the ground. So we were trying to really limit the amount of thermal conductivity that was in the building. And you can see it in more detail there. Then one of the things that's really important is that you actually think through how you're going to put the windows in. Now, this is an existing building. So what were we doing? Well, we were pushing the windows to the inside of the building. So the windows sat in a wind framer system, which we put onto the building, which is called ISOCHEM wind framer system. And the windows then get pushed to the inside of the building. We had a problem with this. We had a real problem with this because when we took a measured survey of the existing building, we didn't actually look at the verticals that much. We thought the building was built perpendicular and straight. As you can see from the laser, it's not. The building leans in, it's a bit like Leaning Tower of Pisa. So it actually causes a few issues with this wind framer system because the walls actually lean in, they just go in slightly. So we had to fill that in a little bit on the inside. So it's great, you know, in the catalogues and everything, it's great. But in reality, working with older buildings, I'm not sure if it's the best solution. But Yeah, you live and learn. So that's something. And you can see there, the purple stuff around the window is us trying to seal the window and seal the window frame effectively in the wind framer system. That's called passive purple. And then you can see the parge coat there on the existing brickwork before we close it up. And we'd be doing air tests all along. One of the things also to really think through when you're doing a passive house or an EnerPHit project is you've really, at the very early stages, think about your mechanical and electrical, your MVHR, and exactly how it's all going to work. So as you can see here, we've got holes in the steelwork, and the holes have got plates over them to strengthen them because we knew exactly where the mechanical ventilation needs to go. So we could actually we could pre-think where the holes in the steelwork would be for the ducting to go. And that's really, really important. And so we had a hybrid. We thought where the ducting goes, where the stack is, and so forth. It's really, really difficult. And you've really got to think this through early, 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 early. That's my big message. What you see here is our data sheets. So these are our data sheets that we were sending to our certifier. And these are the data sheets which show all the sort of technicalities that we were dealing with. As you can see there, as we were going up within the building, we were ensuring that all the pipes were covered with Armacell insulation, which is very good quality insulation. We were making sure that all the ductwork was covered and insulated properly. And then at the same time, it was also airtight. So you can see all the passive purple being painted on. You can see tapes put on. And then you can see the grille that we actually put in specifically to deal with our MVHR. Then came the steel frame and the roof. The roof actually came to be around March, April 2020. And we realised we couldn't get the glulam beams and because lockdown occurred. And we were working with less people on site, so we were working with one team at a time. And the beauty of it is the engineers gave us a solution for building these beams ourselves. So we built it out of plywood. We went to a CNC manufacturer just outside Croydon, and they were made out of plywood and glued and screwed. And we created our own, effectively, glulam beams. And it's just very much like a Wellington bomber. If any of you know about building aeroplanes or making aeroplanes, it's exactly the same sort of thing. I mean, I used to make balsa wood aeroplanes, and it's a very similar sort of technique. We filled it with Styco wood fibre insulation. That's quite a thickness of that. It's 300 mil. But what we didn't do with that was we staggered it. So this was staggered over the entire curve of the wall, of the roof. By it being staggered meant that the air and the gaps in it would be would be covered. And the idea there is that we didn't have any cold spots for any condensation to occur or any air leaks, effectively. And you can see it there as how the roof was actually constructed. And the plywood was very thin sheets. So we would use two sets of thin sheets of plywood to get the curvature on the rib. And then you've got the Styco insulation, so rib, and then you've effectively put the thin sheets of plywood. And then that was covered by zinc, with a zinc roof. So it was zinc. But this is one of the most important things, toolbox talks. You have to have toolbox talks with your builders. The builder on the right is a chap I've been working with for the last 15, 20 years. He's never built a passive house, but at the same time, I was talking to him, explaining to him, these are the different tapes we use, these are different airtight tapes. This is how to connect the roof to the wall. And on the left-hand side, you can see sort of tricky detail effectively and how much tape we used and how much membrane we used. It was considerable. If I was doing this again, I'd probably use less. I sort of over-engineered it a little bit here. So really, I think I overspent a little bit there on too much tape. But at the same time, you've got to get the right tape for the right scenario. So it's really important. We had all these different tapes and boxes on site. I remember coming along one day and seeing gaffer tape being used. And I was going, what the hell? We've spent a load of money on this tape. And then, gaffer tape's being used. So again, going and talking with your builders is really, really important. So I've got the builder here on the left, on the right-hand side, and I've got the roofer on the left-hand side. And then we're looking at the details. We're looking at the air tightness, and we're discussing what we need to do. It's the easiest way, talking through what you need to do. Anyway, moving on from the tapes, the next thing was air testing. So as a standard, with any contract, even working with different people, I use a minimum of 3 air tests. 3 air tests per every single EnerPHit project or passive house project we do. The first one is without the windows. The next one is with the windows, and then we do a final test. Now, what's really important, you can see there with my little video, I'm going around with a smoke pencil and I'm seeing where it's leaking before we close it up fully. So we can deal with this. We can deal with this at an early stage. Why is it leaking? What's wrong with it? And, we can actually deal with that before we close it up. Imagine if that was closed up with plasterboard and, well, we didn't actually use plasterboard, but we used cement board. But if that's all closed back, you'll never find that little leak there. And again, one of the top tip here, if you look on the photograph on the left-hand side, I've left the windows, and around the windows, I've left all the tape exposed before we closed it up. What's the reason for that and the rationale? Again, exactly the same thing.
So you can see
You can see where the leaks are. You can see if there are problems. You can see that those problems, and you can test those problems, and you can then see if there are any leaks, if there are any problems. And when you're doing the air test, you're pressurizing the building or depressurizing the building, you can see where it's leaking, where it's not leaking. We can deal with it straight away without it costing us a fortune. That's such an important aspect of working with a passive house. Here you can see an end wall, and we used wood fiber insulation. We were trying to use as much wood fiber with a lime render, so the water vapor could permeate through, but the building was airtight. This stuff is an absolute bugger to cut. Yeah, it's really hard to cut and to work with, to get these bats in very easily into these spaces. So what we ended up using was an airtight foam, which isn't necessarily the best solution. If I did this again, I'd probably use a different system. But again, you can see there on that wall the styco boards, and you can see the little gaps. Therefore, we had to use really sort of effectively an Ilbrook airtight foam around those to make sure that they were tight and it was airtight. And there you can see the hybrid system for the MVHR. So we've got the big ductwork working in the riser, and then you've got the smaller ductwork coming off the big ductwork going to each individual room with the plastic pipes. And we've got silencers and so forth on that. And one of the things which was really difficult was working out the risers. We thought we had plenty of space, but by the time all the insulation and the armor seal came into play and all the insulation that we needed for Passive House, that was so tight, that riser space. The builders wanted to kill me because basically we didn't have a lot of room to maneuver within the riser space. Again, it's something that I would really highly recommend, and this is something that I found with working on an EnerPHit project, is I would highly recommend working with certified products. If you work with certified products, you will find out that through PHPP, it works. That's Passive House Planning Package. It works much easier and you'll have a lot more data. So we try to make as many of the products that we work with as Passive House certified products. So that's quite important. Again, more air testing. And you can see from this, we were doing these air tests at all times, 3 times, and we managed to get it down to 0.98. 0.98 is really good for a Victorian building. Building regs is 10 air changes per hour. So, come on, this is fantastic to get to this level in an existing building with a curved roof. And here we have the final building. The final building, we finished it off when we actually finished the building, and this is what it looked like. So what we ended up doing is, you can see the solar shading, which was in the brickwork, and the building was finished. We spent quite a bit of time on the interior design, but there what we've got the blinds in the brick reveals. The windows are set back and pushed back, and you can see the curved roof coming through. Quite deep reveals. Those are the Velux windows with the blinds on the roof. But that was pretty much when the building was finished in sort of 21, 22, and we moved in. We had to move in very quickly because the bank was asking us to change it to a mortgage. So we had to cash in our loan effectively to a mortgage, which we managed. But one of the concepts with this was to try and get as much light in, was to try and create as lightweight a staircase as possible in this industrial building so that we could bring the light into the downstairs because it is quite dark. And that was the idea behind the curvature and all the glazing. And the glazing is angled really, so the glazing is at an angle on that curved roof. And again, you can see the deep reveals, and they are Passivhaus Velux windows, and they are Josco Passivhaus doors and windows in there. We also tried to use tall doors internally. They're all sliding doors, sliding pocket doors. And the reason was because we didn't have a lot of head height. So we were trying to create a greater, grander space by having taller doors within the spaces. Again, you can see there we don't have a huge amount of head height, but the space is quite big and large and it works quite well. That was before we'd done the garden. And this is pretty much how it is now on the right-hand side. So we're all living there. There's my two kids. And on the left-hand side was when we'd finished it. And our cats are loving it. And it was sort of filmed on Channel 4, and a lot of people were sort of quite controversial about buying a Passivhaus cat flat, which I never actually bought in the end. I just opened the door now for the cats because I wasn't going to spend 1,500 quid on a Passivhaus cat flat. But it is worth it if you do need it. But our cats are fairly trained, so they go in and out when it's necessary, basically, and someone will open the door. There's enough people in the house. As you can see, I've got two hobs, and that's primarily because we like cooking, all of us. And we sit around that table and we all cook. We all cook basically. All of us have fairly individual lifestyles. The kids are all adults now, and I've got to try and get rid of them, to be honest. But they seem to like the house quite a lot. That's now with the house finished. That was taken last September, I think, and we just finished the garden. We're still doing works to it. As you can see, we soot washed the front facade there. That's the southwest facade. And you can see all the solar shading in there now. So we've got solar blinds in the windows, which come down. They're external blinds like you get in the continent. And they come down to prevent solar glare. We've also got a big awning on the glass on the sort of kitchen area. And again, that helps with any solar glare. So the building stays fairly comfortable. I've got quite a lot of data. I think most it really gets to is maybe 26, 27. When it's 38 or something outside, that's what it's got to. But if you bring all the awnings and you put all the shading in, it will stay around 22, 23 if the shading's down. So it shows you how much you can do with just external shading rather than with cooling. We have no active cooling. Everything is solar. We didn't do the soot wash on the neighbour's side because they got so fed up with us building over lockdown that getting a ladder up there on the neighbour's side on the other side of the fence there proved to be quite difficult. That's it. That's me and my partner Eva, and we live in this Passivhaus certified building, which we've now live in it. The kids live in it. The kids' girlfriends and boyfriends live in it respectively. So it now works for all of us, and it's a fantastic house. We love it, and it's a great way to finish off on the project. And we love it, absolutely love it. And I just wanted to sort of thank you all very much for joining us.
Yeah, thank you, Richard. Actually, what an absolutely stunning project. It's also very clear that you've got a great eye for interior design as well as for the actual building itself. Absolutely stunning. It's lovely to see. Thank you. We don't have any questions yet. We have found from previous sessions that people are a little bit shy to start off with. So I guess it's just a quick question from me, really. I guess, and maybe this is a little bit unfair, but what would be the one thing that you didn't do that you wish that you had done, or that you the one thing that you did do that you didn't need? I don't mind which of those that you answer, but from a kind of a learning perspective, which would you say?
Right, okay, the first thing that I would say is the most important thing is to do a proper BIM cloud survey of an existing building, because we did a measured survey, And what we didn't get was the leaning of the building on the inside, the fact that the walls leaned inwards slightly. So it was only about, 1 or 2 inches, so maybe like 50, 60 mil, but that's a lot. That's a lot. And when you're working with straight or, something like the ISOChem, the wind framer system, that proved to be quite difficult to fill in those gaps. The other aspect was to understand air tightness a little bit more. I overdid it, and I think I overdid it with the amount of tapes. And had I known, I probably didn't need as many tapes, and I used more, and I could have done more with just using passive purple in certain places. But I was slightly worried, so we did a lot of taping and jointing, probably more than was necessary, I think. But and that was a little bit of a cost. Um, if I was to do the project again, those are the things that I would probably omit or take out and try and do a little bit better. Other aspects with it is don't do it over lockdown.
Of course, none of us actually knew how long that would be, though, did we? So,
Exactly. I
so yeah,
annoyed a lot of neighbours, I think, because we were banging away for about a year, and everyone was at home and they were working from home, and it got, we had a sort of WhatsApp group of people complaining, so that was quite difficult, and
yeah,
but I think anyone who's built over lockdown or has tried to build over lockdown, I think it was the same, the world over.
yeah,
Yeah, and
yeah,
it's now the neighbours are quite nice. So slowly, 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 especially now the garden's there.
yeah.
That's really that's good.
You talked about air tightness actually, and Joachim has asked a question actually that you may have answered in your answer, but how did you do air tightness testing at times when not the entire building was airtight yet? I think
Ah,
this is what you suggested.
yeah, that's very important. So what we do is we do air tightness tests even when the windows aren't in. And when the windows aren't in, what you do is you tape up a load of DPM or anything that you have, which is an airtight membrane, and you tape it up. You tape it around the window reveal and window frame. So effectively, if you know that the structure's in and the roof's in, and you haven't got the windows in and everywhere, then what you would do is you would tape up the holes. So, for instance, I know that if I can get sort of an air tasting of about 1.5 to below 2 air changes per hour on a building, I generally know that I can get to an EnerPHit or a Passivhaus standard by the time I get the windows in and get the air tightness in properly. But what I'm looking for at that stage is I'm walking around on the inside with a smoke pencil and I'm looking at the structure and I'm looking for leaks. That's what I'm doing.
Excellent. So we've had a question. Did you consider timber structure instead of steel? And did you do any carbon calculations?
Yeah, we did do the whole carbon calculations. We did the embodied carbon and we did do the carbon calculations. The problem with the timber structure was that it wasn't strong enough to hold the floors. I'd say this is a hybrid structure because the floors are timber. The steel frame was only because if I'd done the whole thing in timber, I would have had a lot of posts going in the insulation layer. So the idea is that there's only, I think, four posts in the entire front of the building going down. And so therefore we've got 150 to 200 mil of insulation all on the inside of those walls. If we'd done it in timber, then we would have had a lot more stud work and then a lot more stud work with a lot more insulation around. And also the engineers at the time were saying, I think the material aspect of that wouldn't have necessarily been the solution. The roof is timber, the floors are timber. The only bit which is steel really is the steel work is there to support the timber joists. So you would have also lost space with the bigger spans because you might have done it in flitch beams, but really I think the steel was the most economic solution for that project. We did go through that because I was thinking that because of the timber, but the engineer was like saying no.
Okay. Robin Dreyer also loved the building, but he said you mentioned BIM. Can you elaborate how you managed BIM with Passivhaus?
Okay, so what we end up doing is we use ArchiCAD. So we use a bit of software called ArchiCAD. And with Passivhaus, we use PHPP, which is a separate for Passivhaus planning package. That's an Excel spreadsheet. And we don't integrate that directly with ArchiCAD. There is software which you can directly do that. But what we were doing was we were testing it. We were working from one program to the other program, and we're testing it. We didn't spend the money on the integration aspect of that. We also have a tool which we worked at the very early days with, which is called Design PH, and that allows you to test the PHPP with a SketchUp model. So what we've done is we did take our BIM model, import it into SketchUp, and then work with Design PH at a very early day. But then later on, we were actually testing it more with PHPP rather than Design PH. So we were actually doing it through the full-blown Passivhaus planning package.
Excellent, thank you. Callum asks, is that gel detail used under the base of the steel columns in any situations?
The jam detail, no, the detail that I was showing you with the ferret plate, I'm not sure which detail you're talking about actually. So
It
I'm
just
not.
says the base of the steel columns.
Oh, the base of the steel columns, the steel columns in the lower ground area, sitting on ferret plates and they're raised up over the top of the delta membrane. Then you have the insulation, so you don't see it, but it's used everywhere. Yes, we use that detail everywhere, primarily to allow for, not allow for thermal bridging. So there is everywhere. There's nowhere where the steel actually touches the outside structure of the building. We've really tried to avoid that. So effectively, we thermally bridged the entire building, so there are no thermal bridges. That's what we were trying to achieve.
Excellent, thank you. In fact, Gary asked a question, did you undertake thermal bridging calculations to
Very
work
much.
out the PSI value for your PHPP, or did you just use the standard default value?
We ended up doing a mixture of both. Yeah, so we did, in the end, we did do thermal bridging calculations is the answer to that question. Yeah,
Yeah.
we ended up doing, but we worked with both really, and then we worked with the certifier, we worked with Ecospheric as well. So we worked with a number of people, but we ended up using Firm for some of the calculations, and we were we were working with a number of different programs, and yeah, it was quite complicated. Is the bottom line, but
Okay,
it's slightly beyond me. And I was going back and forth with Ecospheric and trying to work out what we were doing and what we weren't doing. To be frank.
thank you. Mike asks about solar PV, whether any solar PV was installed, how is heat and DHW demand met, and what EPC did you end up with?
Okay, we only ended up with a B EPC, yeah, and that's primarily because we didn't have the solar panels installed, and I still haven't got the solar panels installed. I've got a Mixergy tank with a solar inverter, and it's all there, ready to take the solar panels. Due to the southwest curve roof, I'm trying to find a flexible solar panel which has got longevity that will go in between the ridges of the flexible roof. It is on the planning permission, and it was there. The wiring is there. I just haven't got round to doing it, as we did run out of money. And I'll be frank with you, you're right. The heating demand for the hot water with two, two teenage, 21-year-old and 19-year-old, and then also their respective girlfriends and boyfriends and partners. Um, that's probably the most expensive single aspect of a bloody building. So it's well worth my while to do that. And I did look into it, and I should be doing that. And the problem is, every time I look, it gets cheaper. When I go on to some website and I find something else, and then I go something else, and the technology keeps on changing, and I can't really make up my mind as to what to get. And at the moment, I'm struggling because I also want it to look nice from the front, You know, I don't want to have square panels just put on a curved roof. So
Mm.
I'm looking for a flexible panel or semi-rigid, which I
Okay.
haven't found.
Okay, thank you. A brief question from Angus, just asking if the webinar has been recorded. Yes, it has, Angus, and it will be circulated. Not sure precisely when, just depends how much editing is needed, but we will make sure that we do get that over to you. So another question, this one is from an anonymous attendee. You describe the curved roof as generated by a desire to maximise usable space within constraints of ridge and eaves. What assessments on impact of thermal envelope and energy performance did you take in this decision, and did it have any actual impact on performance?
It didn't have any impact that I can see on performance. We we Oh gosh. Now that is, in terms of technicality, it is something I did work with the certifier, and I worked with other people. So to be frank, it's not something I just gave them all the build-ups, and we worked with the build-ups. And in terms of thermal performance, for thermal performance and the staggering the Styco insulation, staggering that, ensuring obviously because it's a cold roof, yeah, so it's not a warm roof, it's a cold roof. So you've got the zinc on the curve is acting as a rain screen, and then underneath there's it's ventilated, and the idea behind it was that any water vapor would be able to travel through. That's why you see the purple passive on the roof as well. So in terms of thermal, we were really more concerned about interstitial condensation, about condensation buildup, I suppose, more so. But in terms of, we also knew that within the framework of the ribs and the way the ribs were built, we would also build and worked with the Styco insulation at that point. So the answer to your question is we looked at all the build-ups in a static, linear aspect, not in a curved aspect. Um, yeah, that's quite an interesting point. Maybe I'm not sure whether Ben or any of the guys in Ecospheric did as well. Maybe they did, but that was all submitted to the PHI. So whatever we did, I think we did correctly.
Thank you. Wahim asked another question, which is, why did you end up insulating from the inside? Was this mainly for heritage reasons or space restrictions around the exterior?
Both. Primarily, if we insulated on the outside, if you saw the location plan, the house is surrounded by 13 back gardens of other people's. So if I put anything on the outside, I would have had to knock down the brickwork. I'd have been over the building line. So it had to be on the inside. That was really the issue. And then the aspect was we liked the brick, and the brick works from a heritage point of view. It's in a Victorian sort of street, or most of the buildings there are either Edwardian or Victorian. And if I'd insulated on the outside, people would have lost their garden. It would, because I wouldn't have been able to do it as a bottom line.
No.
So, effectively the tea cozy goes on the inside here.
Yeah. So Delphine asks, how challenging was the external roof insulation junction with the internal insulation to maintain airtightness?
That was a big challenge, but we worked it out. Those were the sketches that we were doing early on, and we worked those sketches out early on. That was probably one of the big challenges, but we ended up spending quite a bit of time on that. And yeah, you can see that with the in the presentation there was that sort of presentation slide whereby we had the curved roof, the purple going, and the tapes. It was before I was talking about the tapes, and that was that junction. So we had the insulation. The insulation touches from the roof to the wall inside of the walls. So it's not that complicated. It's more about the air tightness, which is the complicated aspect there. That's what you had. That's what worried me more. Hence the sort of doubling up on tape, to be honest.
Yeah. So another question here, the house usually doesn't have cooling, but do we still need MVHR instead of using normal mechanical ventilation locally or opening windows?
Okay. I tried to persuade my wife about this as well because my wife loves opening the windows in the morning. She's go, oh, I don't want to live in a passive house. I don't want to do that. all of this. It's a classic scenario. And the MVHR, the problem that you have is you just do a normal sort of like extractor fan in a bathroom. You're taking, that's not only is it drafty, but you're also taking out that lovely hot air you've got in that volume of that house, and it's going straight out into the atmosphere, and all that heat, when it's like, 0 degrees outside, goes. So the MVHR is really, really important. We don't have cooling, but what we do is have purge ventilation. Those Velux windows are on solar-powered actuators, electric actuators. They open. Yeah, so they open, and they also have solar blinds externally on them, and they basically stay on there, but you can open those as well. So when it's really hot in the winter, and as I say, there's a fair amount of glazing there on the southwest side, you end up getting evening light coming straight in. And what we end up doing is we'll just open maybe the downstairs doors onto the garden, and then the roof lights open up as well. You can just press the remote control and you can open up the roof lights, and you get this lovely draft coming through the house. So if it's too hot, you've got the differential of pressure, and that basically gives you that draft, and it does get a nice draft through it. The issue really is we haven't included cooling at all. We haven't got any like ClimateCool or anything else in the house. We haven't really bothered. And does it get too hot? As I said to you, if the solar shading that we've got on the southwest side isn't down, and we go away for a weekend or something, or no one's brought the solar shading down, the house can climb up to 27, 28 degrees if it's like 38 outside or something of that nature. So really what we use is we tend to use the solar shading, but mechanical ventilation just straight out, I would never do. You can't really do that in a passive house.
Okay. Mike asks, how did the engineer sign off the calculations with DIY glue lamps? Have I got the right
DIY glue lamps. Okay. Yeah, DIY glue lamps. Right. They're not really DIY glue lamps. The engineer specified the glue. He specified where the screws should go and the bolts. Yeah. So it wasn't sort of like a Heath Robinson glue lamp. We actually, they were made, as I said, just outside Croydon by a fabricator. And it was effectively plywood, which was sandwiched, multiple layers of sandwich. And the glue was specified, the bolts were specified, and everything else was specified. So effectively, that all got signed off, and not just the engineer, also the structural engineer, building regulation. It all got signed off on that basis. Yes.
Yeah,
They weren't
and Mike
really
just
DIY because they were staggered. Everything was staggered. It was calculated. We had proper drawings of it. Yeah.
Yeah, and Mike just adds, great project, by the way. We have also had a question from an anonymous attendee. Sorry. So when you mentioned using the foam around the insulation and that you would do things differently now, it would be great to know what you would do.
I would use a slightly different insulation. I think I wouldn't use such a crumbly insulation. So what I used is I used Ilbrook airtight foam around that insulation where we were trying to get in between the joists. There are different products out there, but I would use maybe a different type of Styco insulation. And that was a little bit too crumbly for that stuff. That was effectively, some of that was the leftover remnants of what we were using on the roof. But to be frank with you, I'd use a slightly denser one because that was quite, when you cut it cut in a really bad, just crumbles, yeah, around the edges. So then you have to sort of use something. But that wall is covered with cement board. So effectively, we've got a cement board over that wall, so it's quite well protected. My anxiety in using any spray foam, even if it's an Ilbrook one with air tightness, is spray foam is spray foam. It's not as good as a taped joint. So that's probably, you're right, that's probably something I would probably look at in a different manner again.
Yeah, thank you. Couple of final questions that are coming in. Tony did just ask, did you find yourself having to make performance compromises to suit the UK supply chain or planning constraints?
Not then, but now, yes.
Yeah.
So the issue is at that point in time, really, we had a lot of. I was managing to still get a lot of the supply of items because post Brexit there was still some availability. I find there's lesser availability now. So yeah, there's lesser availability now. We work with some very good suppliers like Y. We've worked with a lot of different suppliers who are really good in the UK, specifically passive house type suppliers. For the paint, we use Graphistone. For so most of the products we could get in England. Um, there wasn't anything specific that we couldn't get hold of that I can think of. The only thing that really was the windows, I suppose, from an embodied carbon point of view, they're Austrian. So bringing in
Mm.
Austrian windows, from a carbon footprint point of view, isn't that great. But there aren't that many manufacturers that do such good quality windows in the UK that I've come across that are actually made here. So yeah, it swings and roundabouts on that one.
A question about the doors here from an anonymous question. They have a door with low ceilings and they like your pocket door solution, but actually, how have they turned out in everyday life?
Okay, the pocket door solution is quite good. In everyday, I really like them, and some of them are fire rated as well. So just you've got to be sure that you specify the right ones for the right products. The doors themselves are provided by Josco, so they were provided the door blanks with the walnut finish. It's a walnut finish on them. The actual okay. The issue that you've got with the pocket door, we doubled up on the partitions there with 2 layers of cement board when we were creating that. The issue that you've got is noise does travel from the corridor into the room more because you've got a pocket door. Even if you've got a because you haven't got any insulation where the pocket goes into. Um, does that really bother us? Not really, but it's not as robust, I would say, as a solid wall and then a door. But the reason we
Yeah.
did that is because we were trying to get as much light down that opening space, which is the sort of atrium area with the light above in the curve on the staircase to get it down onto the ground floor. And we wanted the staircase and the hallway not to sort of be like a hall of doors. So having the pocket doors, it sort of looks a bit Star Trekky.
Excellent, thank you. There are a final few questions, and I'm conscious we're right at time, but if I can just quickly ask where you got the external door shading from. This seems rare as hen's teeth on domestic buildings this side of the channel.
Okay, so the external shading. So if you're looking at the pocket external grey shutters that we've got, that's European. It's not. That all came from Josco. That all came from Austria. Yeah, so the external shading on the windows came from there. The awning itself, I organised that, and okay, to cut a long story, that's not that great. I bought it on bloody Alibaba. So it was on AliExpress, to be honest. So it was something that I organised, and it was Alibaba, and I tried to get that. That's why it took a little bit of time, but it got shipped over. It took about 6 months. Yeah, but I did the drawing, got the right size, and when it came over from China, I mean, most of the stuff is made out there, not all of it, but most of it is. And so I wanted it specifically for that size and that house. And it's also got lighting, integrated light, LED lighting in it as well, so we can sit underneath it at night time and open the doors up, and we can have a glass of wine or whatever and look at the goldfish and the bloody rabbits.
Lovely, excellent. Well, look, thank you again, Richard. That was a really interesting session, and we also had some really great questions from our audience as well. So thank you to everyone who came today. Just as a reminder, this session is part of a wider Passivhaus Retrofit case study series. If you wanted to find out more, if you just scan the QR code just there, there's all sorts of information on the Passivhaus website. There's a link to the last couple of sessions that we have as part of this series. You can also talk to an expert, explore free guidance. You can have your questions answered via the Retrofit FAQs, and get started with Passivhaus Retrofit information for homeowners. So lots of information on there. Please do visit it. And once again, thank you, Richard. A really great session, and an absolutely stunning property. So thank you. And thank you to everybody who came today. We really appreciate you all coming and joining these sessions. Thank you so much.
All right. Thank you very much.
Thank you.